Hello again. One more video for lesson 4.9. This is the composite transformations on trig functions. This is for algebra 2a, and we're looking at this last example, which kind of puts everything together in one place. So what I've given you here is some information about a particular function, information about the properties, the amplitude, the phase shift, all of that stuff. We are going to write a rule, and our rules are going to look something like this. I put these up here, by the way, just to remind you of these letters that we use sometimes to represent these things. So the a value would be like what you're multiplying x by and so on. We're going to write some rules. We're going to apply those rules to the equation. And then once we have the equation, we're going to figure out how we're going to draw a graph of that thing. Okay. So, and then also I should mention that back here, this originally said to write it in this form with sine here, even though it tells me to write a cosine function. That kind of just goes back to the point where we said that these could all technically be called sine functions, right? So it's totally okay for us just to swap this out with cosine, all right? And that means the same thing. So when I start wanting to write my size change rule, my size change on my x's, that's going to be affecting my horizontal shrink and horizontal stretch, which really is going to change the period of my function. Now the period is the only one that you have to do a little bit of calculation for, and it's not a difficult one, but we want to think about what happened to our period. So I don't care so much that my period is 6 pi. I care about how did it change from what it was originally. And remember, when I say originally, the parent function would have a period of 2 pi. So we somehow changed from 2 pi to 6 pi. The question is, what happened? That's what that a value represents, is what happens to the period. Well, here, to go from 2 pi to 6 pi, we clearly multiplied by 3. Okay, so when I go to write my rule, this is going to be a 3x to show that my period got multiplied by 3. My amplitude is a 2. Originally it was a 1, so my amplitude doubled. Okay, the height of my graph doubled, and that would be a vertical stretch by a factor of 2. So there's the first part of my rule. For the translation, that's a lot more straightforward here. I can just look at the phase shift and vertical shift and put those two things in a rule together. So x minus pi over 2 and y minus 3. And that's my rule for my transformation. So these two rules together would accomplish these properties that are listed up here, kind of going backwards from what the last few questions were asking. So now I'm going to take those rules and put them into an equation. Okay, and remember that when we do that, we start with the translations, all right, because we want to make sure that our scale changes get applied to those translations as well. All right, otherwise, if you translate first and then do your scale change without applying it to the translation, things will get out of line. Things will not stretch and shrink the way they're supposed to. Okay, so back to what I was saying here. My original function is going to be cosine of x, and I'm writing it all stretched out like that on purpose. I'm going to start with my translation rule, so that means the first thing I'm going to do is put in my pi over 2 and my minus 3. Remember, when they go into the equation, they go in the opposite of what you're seeing here, so this would become a plus pi over 2 in parentheses here. And then the minus 3 would go in over here with the y like a plus 3. But then if I move it back to the other side, it will become a minus 3 again. So I'm going to just put it in there as a minus 3. So that equation right there would handle my translation. This would accomplish the translation piece of this. It would not change the period or the amplitude. Okay, to do that, I want to do the opposite of what I see here. So I see multiplying by 3. So I want to take this thing with the x, and I do want to apply it to this whole thing here. Okay, because that goes back to that thing we were talking about, that you want to make sure the scale changes get applied to the translations as well. I could divide this whole thing by 3, like I could put this over 3. I think an easier way to write it is with a 1/3, because multiplying by 1/3 is the same as dividing by 3. And notice I put it out in front of those parentheses so it would apply to the whole thing. And then where's my other one? 2y. That's going to affect my amplitude. That means that there's going to be a 2 hanging out right there. The only other thing I might do with this equation is clean this part up in here. Okay, this is exactly how we want it to happen mathematically, but we could make this look nicer, right? So I'm going to make this y equals 2 cosine of 1/3 x. And then if I distribute that 1/3 to the pi over 2, that's really going to give me pi over 6. And then minus 3. And I just quickly want to look at the graph of that thing and make sure that all of these things that we thought were going to happen over here actually did happen. And then we can work on drawing the graph. So I'm going to head over to my buddy Desmos. Come on. There it is. So you'll see here that I graphed the function that we just came up with, the equation that we just wrote, 2 cosine of 1/3 x plus pi over 6 minus 3. And we just want to verify that all of the things happened the way we thought they would. So one of the things we said is we thought it would shift to the left by pi over 2. If you think about it, the cosine function typically starts with the top of this bump here being right on the y-axis. And I'm going to zoom this in a little bit so you can see it. Now if you look at it, the top of this bump is at negative pi over 2. Okay, I keep pointing to the screen and I realize you can't see that, but this bump has been shifted to the left by pi over 2 when typically we would find this right on the axis. Okay, so everything shifted to the left by pi over 2. Also, this shifted down by a factor of 3, and if you can't quite see that, let's try this. Let's just graph the line y equals, negative 3 because it shifted down. Okay, make that a different color quick. Dotted line there. Okay, so if you look at that y equals negative 3 line, you can see that that's kind of like your new x-axis, right? That's your new center line. All right, so we can see that this shifted down by 3, which is what we thought would happen. The period is supposed to be 6 pi, correct? And so this one's a little bit harder to see because of that shift. But if we go back to here where we said this was negative pi over 2, and then we look at the top of this bump, which is 11 pi over 2, that's a total distance of 12 pi over 2, which is equal to 6 pi. So this thing does have a period of 6 pi. And then also the amplitude, and again for that we have to consider it coming off of that dotted line. From that dotted line to the top of that bump, sorry I zoomed in too far, now I'll zoom back out. This is a distance of 2 units based on how this y-axis is numbered. Okay, so I do have an amplitude of 2, and then you'll notice it also goes down to here. So just to verify that that equation that we just wrote does all of the things that the problem said it should do, okay, that we wrote our equation correctly. Now the question is, how do we draw this thing? How do we draw this graph other than looking at it on Desmos and just picking the points right off of there? Like if you were forced to graph this by hand, how would we do it? So let's talk through that real quick. What I would do for that is I would start, and I showed you this a little bit in class yesterday. Sorry, I'm trying to zoom out a little bit for you. Oh, I can't zoom out. Very helpful. I just want to make it so you can see the equation and stuff at the top too. There we go. Okay, so I'm going to start with a table, and you'll notice that I'm going to do this almost in the center of the paper because we're going to build off of each side of it. So I'm going to start with xy, and I'm going to start with the original cosine function, so the parent function for cosine. And I'm just going to sketch this off in the corner so we remember. Okay, I'm looking at these 4 points. What's happening to my critical points here? So those points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then if I'm looking at cosine values, this starts at 1, 0, negative 1 is over here, 0, and positive 1 again. So I start with the coordinates from the parent function. Okay, I start with what the original cosine graph should do. Now I'm going to apply my 2 rules, and I know that I told you to apply the translation rule first when you're writing an equation, because equations you always build backwards. Okay, you do plus when you're supposed to subtract. You do divide when you're supposed to multiply. You start with addition and subtraction rather than starting with multiplication and division. But when we're applying it to like coordinates like this, we're going to follow order of operations. So we actually do our size change first. Okay, I mean scale change. I have said that just about every time. So, cutting that one a little close there. For my x value, notice that my rule says I'm going to multiply by 3. For my y values, I'm going to multiply by 2. Okay, so I'm taking all of these values from the table here and applying that rule to them. So 3 times 0 is still 0. 3 times pi over 2 is going to take me to 3 pi over 2. 3 times pi is 3 pi. Okay, 3 times 3 pi over 2 would take me to 9 pi over 2. And then 3 times 2 pi takes me to 6 pi. And so you'll notice that what I have now is one full cycle from 0 to 6 pi. That means my period is 6 pi. For my y's, let's double them all. So this is going to be 2, 0, negative 2, 0, and back to 2. Okay, and that would accomplish giving me an amplitude of 2. And then I'm going to add one more layer to the outside of this thing with my translation rules. So over here with the x, I'm going to subtract pi over 2. Whoops. Over here with the y, I'm going to subtract 3. And I'm applying those to these values. So 0 minus pi over 2 would take me to negative pi over 2. 3 pi over 2 minus pi over 2 would really take me to 2 pi over 2, which is equivalent to just pi. 3 pi minus pi over 2, so it may be easier for you to think of this 3 pi as 6 pi over 2, okay, because 6 over 2 makes 3. 6 pi over 2 minus pi over 2 is 5 pi over 2. Man, I'm going to stumble over these words. 9 pi over 2 minus pi over 2 would be 8 pi over 2. And 8 pi over 2 is really equivalent to 4 pi. And then 6 pi, I could write this thing as 12 pi over 2. And then 12 pi over 2 minus 1 pi over 2 would be 11 pi over 2. Now let's do it with the y's. So I'm going to take all these values and subtract 3. 2 minus 3 is negative 1. 0 minus 3 is negative 3. This will become negative 5. 0 minus 3 is negative 3 again, and then 2 minus 3 is negative 1. So if I look at these coordinates, so negative pi over 2, negative 1, pi, comma, negative 3, 5 pi over 2, comma, negative 5. If I had a graph in front of me and I plotted those points, I would get that picture we were just looking at. So let's just verify that. Here's my Desmos picture. Okay, the first one on our list was negative pi over 2, comma, negative 1, and there it is, right there. Negative pi over 2, negative 1. Then we had pi, comma, negative 3. That's this guy right here. Then we had 5 pi over 2 and negative 5. That would be that one. My guess is this next one is 4 pi and negative 3. And that last one is 11 pi over 2 and negative 1. So those 5 points that are marked there in black, those are the ones we just came up with that table method. Okay, so if you had to draw this graph by hand, I know that seems time consuming, but that's the best way to do it, is apply it to each of those 5 points, and then that should be able to make it so you can sketch one full cycle. Okay, I hope that was helpful. I realize that this lesson is a lot to take in, but we will spend plenty of time going over it in class as you need it, and good luck.